We're back 20 minutes later and it started.
Okay, goal today, finish up, talk about domain and range, intro, the set notation, interval notation. I'll talk about how to use your calculator. I know we did that a little bit yesterday. I want to talk about that one more time, just so you can see it. But then the goal today is to really talk about tables. We didn't really go too far in depth on a table. In fact, let's just start with the table and we can move on from there. You guys laughing at me right now?
Yeah, that's
Alright, here we go. This is the first table I'd like you to write down. Okay. X, y1, y2, y3, 0, -3, 4, 0, 9, 16, 16. Okay, I like to write down this table here. This can be our first example, because yesterday we talked about, we introed what tables were yesterday, right? Especially on a graphing calculator, but we've never seen something like this. And I want to explain the concept here, and then I'm going to put a bunch of formulas on the board, and we're going to pick them out. Okay. Alright, so you have your table. I know a lot of you are still writing, that's fine. I have a series of functions on the board. You can see they're all named, F, G, H, J, and K. Goal is to figure out, what the table's actually telling us, and then answer a series of questions about it. Okay? So that's kind of what we're looking at. Okay, we're good to go? Alright, so first thing, let's look at the table. The table has an X on it, because these are my independent variable, it's the thing I'm in control of. Then these items back here, these three, they're y1, y2, y3. They're the values of three different functions. That's what you need to understand. There's some magical formula that when you plug X into it, it's spitting out this number for the first function. When I plug in this number, this is what the second formula gives me. And then when I plug in these numbers, the independents, it gives me those values. Does that make sense what's happening here? It's like three individual formulas. Now, what you'll see in the book, especially I think tomorrow we have homework, I think it's tomorrow. So at least half of the week, basically. They're going to give you this, they're going to give you this table. It's going to have a multiple different formulas on it like that. And then they're going to give you the first question on number one is always, which function in that list, and they give you the list, it represents y1. So they want to know what formula does y1 equal out of these five. And you have to go find it. Now what I mean by that is that you have to use the table and the formulas to figure out which one is y1 giving me. So when I use these numbers and I plug them into one of these, it should spit out these numbers exactly every single time. Does that make sense now? So can anyone figure out which function up there represents y1?
J.
J? Okay, let's talk about why is it J. Okay, I'm going to agree with you. y1, that function is j of x. But let's talk about y. What is j of x telling us? What is j of x formula? What, squaring items? Okay, so we're going to square items. So if we go over here, you square -3. Is that 9? Yeah, it is. Square root of 0, that's 0. Square root of 3, that's 3. Square root of 4, you get 16. I agree. This is the first one, so you're good. Question number 2. Maybe the second question says, which function represents y2? So now that's a different one. So we're already done with j, so check, j is done. So we're done with that one. So now you're going to the other 4, basically. And you're trying to figure out from that table, which formula up there would represent the second one, y number 2.
G.
G? Okay, I'm gonna agree with that. So this would be g of x, because g of x is telling us that whatever your numbers are, you're gonna multiply them by 3 when you plug it into x. So negative 3 times 3 is 9, negative 3 times 0 is 0, 3 times 3 is 9, 3 times 4 is 12. So yeah, so 3 of x is definitely it, so we're done with that one. You guys get the idea of what you're doing, like how you can check. The reason I'm bringing this up is that they're gonna get really tricky on you, and they're gonna really mess with you, because they could look like the same problem. It could look like the exact same numbers coming out of that thing, but there's one subtle difference. Like on that problem, y1 and y2 almost looked identical, like the actual function values. The only difference was that what gave it away was the first one. This one was negative, that one wasn't. And the last one was the difference. All the middle terms in the middle were almost exactly the same. So that's something to kind of think about. All right, anyone know what the last one is? Y3?
H.
H. Okay, because you had to add 12. Negative 3 plus 12 is 9. 0 plus 12 is 12. 3 plus 12 is 15. 4 plus 12 is 16. So it would be H. So those are your 3. They're going to have you test on that. Okay, do we feel comfortable like picking out which function represents which, table? And again, you're just plugging in the x's, it should spit out the y number, but again, those are 3 individual functions. This notation, what you're seeing here, is exactly how my calculator does it as well. Like the graphing calculators always have you program in y1, y2, y3, and you can set up your table. In fact, you could cheat this problem if you had a graphing calculator, because you could program all of these functions in. You could program all these functions in, and because you could see, like yesterday when I was typing those in, you could type in y1, a y2, a y3, you could type these in, all these functions. You could set your table to be these numbers, or at least you could have these jump by this particular number, and then you could figure out which one would represent that certain function pretty easily, because they would all spit out your correct answers. And I'll show you that today. The goal today is to show you like how a calculator can actually do that same exact problem. Okay, before I move on, questions before we kind of go to the second part. Okay, number 2, second types of questions, other than just asking which one represents what. Does y1 pass through the origin? Pass through the origin. So that's the second type of question you're going to have. It's kind of a yes-no question. So what does it mean to pass through the origin? What is that?
Passing through 0, 0.
0, 0, like on a coordinate plane, right through the middle. Does y1 actually hit 0, 0 when you look at the table? Yeah, it does, because the coordinate for y1 was, if I'm trying to figure out, does it pass through 0, 0, right? That's what I'm looking for. Yeah, because this represents x, and this was y1's value. It actually is right there. It did hit the origin. X was 0, y was 0, so it did actually hit the origin. The question you could ask, if it doesn't pass through the origin, what would be the y-intercept? Because if it doesn't hit the origin, it'll hit somewhere above or below it. So like on y3, what is the y-intercept? So it didn't hit 0, 0 on y3, but what number did it hit? 0, 12, or 12, if you want to say just 12, I'm fine with that. If you want to write it as a coordinate 0, 12, or if you just want to write 12, I'm fine with that. That is the y-intercept number. Because if you see, you have to hit x on the 0, because you have to go right, left, 0, but it went up and down 12. So y3 actually didn't go through the origin, it went through a different number. Okay, we're good with the second type of question they would ask. Because again, they're just trying to have you interpret numbers, interpret graphs, trying to get you in that flow of graphing again, get you used to the vocabulary that they're going to ask, get used to kind of this upper level type of tables and sets and stuff. All right, next. Same table again. Where does y1 equal y2? This is a weird notation. Basically, they're trying to, when they actually ask that question, they're asking, do they intersect? That's basically what the question is asking for. It's kind of a yes/no question, but also where, if they do. So it's almost implying that it will cross. So when you look at y1 and y2, do they share similar coordinates? And where is it? So what are the coordinates that y1 and y2 shares?
3, 9.
3, 9 is one of them, 3, 9. That's one of the spots where they cross. 3, 9, and what else? 0, 0. Conversion. And the reason why they do cross is because y1, what is this? This is the y2 and this is y1. These two objects are going to cross twice, and how I know that, this is something that you're going to learn later. This top one is linear. This is something that you'll eventually get in this first chapter. That first function is something like that, right? It's linear, it's going up, to the right. This one is a parabola, or quadratic, if you will. And parabolas have curves, like that. They're very symmetrical. Yeah, well, duh, they have to hit twice. They have to hit eventually twice. That's the concept. Now, that is not the accurate drawing of those, but you get the idea, like how it's crossing twice because of that hole. So that's why this makes sense to me. So sometimes, like, if you know what the formulas are, like they've already had question number 1, you can kind of figure out, like, yeah, it will, but the table should allow you to see that. They're not going to ask you to go find one if it's not on the table. That's not one of the questions they're going to ask you. Let's see, it doesn't look like, I don't know if there's any others that they're going to ask. Y-intercepts, X-intercepts, origin. That's pretty much it. So those are the set questions about your functions. We a little more comfortable with that right now. Okay, now, let's talk about how you can cheat this problem, especially in that first question. That first question I asked you was, which function represents which, y value? Okay, y1, y2, y3. We're trying to figure out which one of these three, we already know it was the middle three, but which ones represented which? This is where you can use a graphing calculator if you had one, and you can actually just bypass the whole question. So I'm going to actually pop this up. All right, and let's actually go through this. Okay. Turn on my animating projector. Okay. All right. That'd be helpful. Okay, so here's your graphing calculator. Goal today is to look at kind of how to type this stuff in so that you're kind of more comfortable with it. In fact, I'm gonna zoom in here a little bit and see if this gets a little bit more clear. All right, so what I'm going to do is I'm going to try to type in these functions. So I have these formulas off to the side, and this is my way of like kind of cheating this original problem. I'm going to type in all 5 of these functions in order, F, G, H, J, and K. To do that, I have to hit this little Y1 button right there. That'll allow me to type in functions. So this is my way of kind of cheating the problem to get to an answer, so I don't have to like think about it or plug numbers in if they're like really complicated looking. So I'm gonna hit Y1, here's what pops up. So it's waiting for all of your functions. Now, the problem is, I don't care, I know this says y1, y2, y3, y4, y5, y6, what I don't care about is that they match the table yet. I don't care about that. I just need to type these 5 in randomly. So I'm gonna go to the first one. So how I type x minus 2, I'm gonna hit the little x button, bless you, x, and then I'm gonna go minus 2, so you can minus 2, okay, and then I'm gonna go down to the next one. And as you can see, that first function is activated because it has a little black box next to it, so it is activated, so it will work. Y2, I'm gonna type in 3x, so 3x. Go down to the next one, use the little arrows. The next one is x plus 12. Go down to the next one, that's x squared, so x, there's a square key. There's x squared, and then the next column down is a 2x. 2x, there we go. Alright, there's all my functions, I'm going to enter, so they're all activated. Now, I'm going to go to the table now. And this table will help me compare to the one that I have on the board in red. And I basically just want to see which one of these kind of matches. So what I'm going to make sure is that my table is going to start with -3. It's going to go up to +4. And I'll just jump by ones. Now I'm going to have a lot of extra numbers than what you guys have, but at least I can see kind of what it's doing. Okay? So to go to the viewing window, the table set, that's F2 button, but I have to hit the little shift key. So shift table set. And now I want to start at -3 and I'm going to jump by ones. So yeah, you can see that. Now I could jump by 3s if you want, and I could just bypass the number 4. You could do that too. Maybe you just don't need the number 4, so I could jump by 3s. I could put that in the next row down. So I'll show you that here in a minute. We'll do this one first. Okay, and so this looks good, -3 up, and it's jumping by ones. Now I'm going to hit the table. The table button's up here, so I'm going to hit that little table button. So I hit shift table. And now here's the tables that I have. And all I need to make sure, and I can scroll over, I can go over. I need to make sure I find the one table that kind of matches mine. So what I mean by matches mine, I need to make sure that the zeros match, the numbers match in those other columns. You can already kind of see like Y2's already been matched up on my table up here. So, let's see, can I have Sam hold this? Like, yeah. Hold that on top and just point it.
Oh, I'm going to, yeah.
So just put it on your desk and do it. Alright, so just try to get that graph centered so you can see this.
That's how we do it.
Yeah,
that looks
very
good.
good. Okay, that's good, right there.
That works.
Yeah, just hold it right there if you can. Okay, so what I'm looking at this thing right here, and you're fine if you wiggle a little bit. The 0, the 3. Okay, I'm looking at those numbers, and then I'm looking at the values that are over here. 0, 0, oh my gosh, she's moving around. And the 3.
Yeah.
Alright.
I was trying to line up with one.
Yeah, that's fine. Alright, so
A lot of pressure.
okay, so those are the ones I'm looking at, because if I can get my numbers to match this table,
There we go.
which you're actually seeing here, it actually did work. I immediately saw I had a -9, a 0, a 9, and there's probably a 12 later on. You can actually see them here in Y number 2. -9, 0, 9, and then it went to 12. That means that if these numbers are showing up on my table, this one, that formula is represented by whatever's in Y2 right now, whatever I typed in. Because it was a perfect match between the numbers. Well, if I go back, this is the one that I typed in Y2. Because if you remember when I was typing these in, this is Y1, this is Y2, this is Y3, this was Y4, and this is Y5. When I was typing those in, I just went in order top down. So knowing that Y2, that's this formula right here. That was Y2 according to my table. So you can use a table to cheat. Now I know, like looking at this is like, whoa, that is really confusing. Because they have extra numbers, right? They have the ones, they have the -1s, the -2s. We can bypass that. So now you can get rid of all those extra numbers we didn't need because they weren't on this table. So Sam, go if you can, I don't know if you can do this, hit this, hit your shift and hit the table set button, that's F2.
Damn.
Boom. Okay, so you're seeing that. Go push down, and I want you to go right there and type in a 3. We're gonna jump by 3s now. Because it's gonna go 3, 0, 3, and then I know we'd go to 6 after that, but, and hit enter. So it set that number. All right, now go shift and hit the table button, that's F5. So now the top 3 is exactly what I needed. So now it's in order by what I needed.
There we go.
So if you can see this, the top 3, -3, 0, 3, now they're right there. they're perfectly in order. I don't have the number 4, I could go find that later, but I have everything else that I needed. Does that make sense? So I can like adjust the table to what I need. If I'm jumping by halves, go by halves. Push the over button if you can.
Which one is that?
The arrow keys, yeah.
Arrow keys.
So we're gonna go over and just go over like another column. There, right there, stop there. So now I'm over to the next column. So now that column says 9, 12, 15. If you can see it, that's Y number 3. That's right here. 9, 12, 15, that's column 3. The third one I typed was this one, so this one has to be Y3. It was exactly the right columns, 9, 12, 15, they're in the right order. So the third one on when I typed it in, is the third table up here. So that's the third one I typed. And now if we go one more over. Boom, Y4. So this is now Y4 in my calculator is these. 9, 0, 9, and it keeps going. So Y1 is this one. Now how I know it's that one? Because that's the fourth function I typed in, and that was this one. That's my fourth function, so that has to be equal to the first thing on my table up on the board. Does everyone see how you can use the table like to cheat? Like you can do it super fast, and you can instantly see what it's going to have. You just have to make sure it kind of works for you and you remember what you typed in. That's why I just typed them in order, so I didn't have to remember it. The calculator does make things easier. Now you can download apps for these. You can put that down if you want. So yeah, that's fine. All right. So the idea is that you can download apps on your phone, on your Chromebooks, on MacBooks, where you can just have the calculator app. Like it does that. Like Texas Instrument puts out an app that can actually do all of this stuff you're seeing. You can do it on iPads, iPhones, Android, and it's free. So like the app doesn't cost anything, which is really funny because they charge, like that calculator that Sam has that I'm letting him borrow, it's like $100 calculator. You could go buy a used iPad, like a used one, not like a brand new one, but go buy just a used iPad from like the refurbished store or from like Walmart or something, and you can buy it about $100, $150 for just an older one, an older model, and download the app for free. So I don't know why people would want to go buy one of those. I understand in college they want you to use it because the iPad can do a lot of other things, but I just don't understand why we still use that thing. They're overcharging for that thing. So, you can download the apps on your computers. Like I can download the Texas Instrument like calculator app, and it looks just like that calculator. It just shows up on my screen. I can type on it. You can actually see me, and I'll probably show you that tomorrow, so you can see it. All right. Questions at all about tables? How to use a calculator a little bit better? Hopefully that kind of explained to you how to do stuff a little bit anyway. All right. Perfect. All right. Let's get rid of that. Let's go to a graph now. Yeah. Thanks. Da-da-da. Okay, we're gonna go to graph. So does everyone have their graph paper? Perfect. We should be on, I think, the second graph, correct? Okay, second graph. Here we go. Good. All right. Excellent. Okay, so got through our table. Now we're going to be graphing here. Okay, so off or maybe above your second graph or wherever direction you're going, I don't know which spot, maybe you're going down, maybe you're going across, I don't know which graph you found. We're going to graph a different function. We're going to graph this thing today. X to the third plus 8x squared minus 16x minus 128. Assuming my function. Now this seems like crazy. It's crazy big. Okay. So, what we're going to do is we're going to type in a few numbers here. So what I mean by few, off to the side of your graph, I want you to set up a table. Oh, this marker's terrible. So you're going to set up a table. On the one side, you're going to have x's. The other side, you're going to have y's. And I want to go from, let's go from -5 up to 5. So -5 up to 5. Okay, what you're going to want, grab a calculator, start typing these numbers into that function, enter them into all those x spots, hit enter, and write down your numbers in your table. I'll do the same thing. I'm warning every class, I'm missing calculators, so if you borrowed one from me, I want it back, because by the end of the week, we will not be using calculators unless they're all back again. So I'll be doing everything by hand. So I'm missing 2 right now. So keep that in mind. Even if you have your own, you won't be able to use it after this week, until I get my 2 back. And it goes further, I'm not directing towards you. I'm just warning every class. It went missing on Monday. This is one of our last problems today. I know this seems silly, but this is one that I just want to highlight something. This is the reason why I brought this problem up. Okay, you're probably looking, I already got my table up here, so you can, hopefully you're filling in kind of your numbers and whatnot.
What about the 5?
What was that?
About +5.
Yeah, I didn't put that one. That one is a 117. So the last one, 5 is 117, sorry, I didn't put that. Okay, now, you're probably looking at these numbers going, Ward, we can't graph that. That's stupid. Why would you give us this problem? You need to know that your graph paper, you can change the scale of the graph paper. Like, you don't have to go by ones, like a lot of us look at this and go, okay, it's going from -12 up to 12 on my graph paper. You don't have to go by 12s. It looks like the x-axis, I'm using like just single digits. 5 to positive 5, or sorry, negative 5 to positive 5. So that's fine, you can use those. So I'm going from, negative 5 up through positive 5. You could double these, like, if you want to like spread those out, so maybe like every 2 hash marks another number for the x-axis, you could do that. So maybe down the road, this is your number negative 5, then your negative 4, negative 3, negative 2, negative 1. You could jump like that. That is totally fine. So you don't always have to go in the order that the book is presenting you or whatever you feel like it has to go. Now the reason why I want you to know that is because if you look at the y-axis, look how big those numbers got. Like that's insane. I can't graph that in a normal graph. All of them would be like way out of bounds. But if you just kind of look, it's going from positive up to like 100 something later. That's number 5 is 117. Maybe you want to jump by 20s. Maybe that will get you in the ballpark so you can kind of see what this graph looks like. So if I want to jump by 20s, that's 0, 20, 40, 60, 80, 100, 120, 140. Maybe that's what you want to do, because maybe this will make a little more sense to you. Because now you can kind of get a glimpse of what this thing looks like. So 5 is 27. So negative 5 is 27, it's about right here. Negative 4 is at 0. What is it? Negative 3 is at negative 35, so that's about right here. Negative 72. Negative 105. 0 is negative 128. Negative 135. Negative 120. Negative 77. 0. And then 117. Holy moly. Joel, try to plot these points kind of like what I did. I'll bring it back to the morning, okay? Because we're going to talk about
Michael Bailey, please come to the office. Michael Bailey. Also, Tristan McFerrin, please come to the office.
Books tomorrow, bring your books tomorrow. I know tomorrow we got a shortened period. Oh, that's right, we're on a shortened period today.